Okay, so this is AC6. We found the sum. We found the interior angle. I like to do this. Just clearly state what my interior angle is. Show your work there, please. And that's it. Can I just remind you of labeling? Because I will ask you to do this. There is an interior angle. Do you remember how to label the exterior angle? It's just like this. Not, right? I see that a lot. It's like, it's somewhere here. I'm just going to go line out and E. There you go, Mr. Dirksen. Figure that one out. Good luck, right? No, you pick one of the sides and travel until you get to the end and then just extend it. So this is exterior angle. And just for fun, let's calculate the exterior angle. What do the interior exterior always add up to? 180, right? Thank you. So you take the 150, which is in here, subtract it, and you get 30 degrees. Or exterior angle, the formula is 360 divided by the number of sides, which is also 30. So you pick which formula you would want to use to get there. It's 30 regardless. What do the exterior angles always add up to? All the exterior angles always add up to a certain number. It's always the same. 360. Yeah, it's always 360, folks. That's the interesting. The sum of interior, that grows. But the exterior remains 360. If you add them all up, all the exterior angles will always be 360 no matter what. So it's a pretty cool property. Even if it has 102 sides, it'll still add up to 360. Okay, number 2, determine the sum of measures of the angles in a 20-sided convex polygon. Convex, don't let that scare you. All of ours are going to be convex. So it's 20 minus 2 times 180. And that actually gets to 18 times 180. That's 3,240 degrees. Okay. So those are actually pretty easy. They're one markers. You just plug in and go, right? This is a special one here. I'm going to write backwards. I'm going to actually make sure you understand that, right? Highlight that if you have a highlighter. This is a backwards example, which you can be guaranteed on a test. Something that requires you to go backwards, you cannot guess. Some students just guess until it works, but it doesn't. So the sum of measures of interior angles in an unknown polygon is 3,060. Determine the number of sides. They're asking you for n. Usually you're given that, now they're asking you for it. And because it's the sum of interior angles, right? The sum of interior, you're using this formula. Sum is n minus 2 times 180. Right? You take the sum, you substitute that in. In this case, they give you that value. Is that mine? No, that's not mine. It's Christine's. Okay, n minus 2 times 180. Right? What do you do now? You get $100. No, I'm just kidding. What do you do now? You have two options. I will tell you the easiest one. 180 is multiplying this, right? So you divide both sides by 180. That's what you do there. And why would you do that? Because when you do the same thing to both sides, you're not altering that equality. So you cancel that out. This you do on your calculator. So you go 3,060 divided by 180. Oops. That's 17. So I'll continue over here. This is 17 now, And on the other side, you have n minus 2. We can get rid of the brackets because there's nothing multiplying it anymore. And then I will keep n here. What happens to the negative 2 when it comes over to the other side, when it crosses the equal sign? It turns positive, right? So it's 17 plus 2. So it's really 19. 19 sides. So that's showing work right there. You got to show the algebra and see how you. I need to see how you got there, not just plugging in numbers. Okay. Number 4, calculate the number of diagonals. They're asking you for what's D, right? In the polygon in question 1. Question 1, that polygon had 12 sides. So the formula is n times n minus 3 divided by 2. Okay, so D is going to be 12 times 12 minus 3 divided by 2. That is 12 times 12 minus 3 is 9 divided by 2. If you like your mental math, you can just divide. 12 divided by 2 is 6. 6 times 9 is 54. Oops. So remember when I drew the diagonals? Can you imagine having to draw 54 diagonals? Right? That'd just be a nightmare. I wouldn't recommend that. So write that down. I'm just using the formula and plugging in the number of sides and solving it. Right? Okay. Next up, we have our truss there, the roof truss for a garage, and it says that ABCD is a square. So ABCD, right? We have a square here. So if they're telling you that all these sections down here are the same, right? So if this is x, then x would be 36 divided by 6, right? You take the whole distance across, you divide it by 6 to get 6. 6 feet is one section. So if this is 6 and this is 6, then the whole thing here is 12. This whole thing here is 12 as well, because we're told that this is a square. So if we figure out the base, we know that everything is 12, right? Does that make sense? Right? I'm just using what I know on one side and transferring that. So everything is 12, right? So it's saying calculate BE. So BE is here, right? They're asking me to calculate that. And you should see a right triangle here. Okay? So for A, I'm going to calculate that here and just quickly draw myself a triangle here. Do that. I would always recommend you do that. Based on this, right, I know that this is 12. And this here is the same as the bottom part, which is just 6. And this is x, right? That's the one. This is B and E, right? That's what they want this stretch here, which is the hypotenuse. So we go x is equal to square root of 12 squared minus 6 squared. X is equal to 108, root of 108. Take the root of that, that's 10.39, and that's in feet. So that this would be a 2-mark question just for A there. So we know that this is 10.39. Okay, just found that. Classify ABE. So if you think about it, ABE, that is definitely a right scalene, because all three sides have a different side length. Yeah. Oh, yes. Thank you. Thank you for stopping me. Yeah. So this is an hypotenuse. So this should have been plus, which throws everything out, right? So 144 plus 36, that's 180. Square root of 180. Look at that, 108. It's not 108, it's 180. Thank you, folks. 1342 it is. 1342, my bad. I wish I could say I make them on purpose so students, I check if you're awake, but I don't. Just a regular rookie mistake. It's still a right scaling though, right? So we're good. So keep that in mind. Good. So we'll just go 1342 here to make sure we've answered that. Classify BEC. So BEC, wouldn't you agree that that is definitely an isosceles, because this side will be the same as this, considering that this is a square, right? Did anybody check if this is an obtuse up here? Because we know that this is 12. This is 13.42. 13.42. That's definitely, this is definitely not going to be an obtuse angle, this one up here. So we'll just call it acute isosceles. So I'm kind of mixing everything up, right? Properties of squares, be aware of diagonals, and so forth. It's kind of like that bridge question we did a little while ago. Okay, given the kite to the right, determine the following. EB, so E to B, this stretch here would be the same as that stretch, correct? Because we know that the shorter diagonal always is bisected. So we know that this is 5 inches here. So that one is fairly straightforward, just 5 inches. Because this is equal to DE if you want to put it that way, right? Shorter diagonal bisects. We got that. And now they're asking for AE. They're asking for this. And that one is trickier. You first, like they tell you from top to bottom is 16. So if this is X here, I will first have to figure out Y. Hold on, no. I don't have enough info there either. Because 14 is the side here. Oh yeah, I do have the 5, so never mind. I can do Y first. This will be my first step, and then I'll move over to that second step. Okay, so I'll find Y first, like this. This is Y, this is 5, and this is 14. Now this is my leg, right? So Y is going to be square root of 14 squared minus 5 squared. That's 171. Root of 171. Okay, the root, that's 13.0767. I can find x, right? So this is important to me. I found y. Now I can find x by just going 16, this is inches by the way, 16 minus 13.0767. And so x is 2.92 inches, which is AE. So this is 2.92 inches. So Pythagorean theorem is a lifesaver here. AB, from A to B, you got to do Pythagorean theorem again. We know that this is 2.92, and this is 5. So this is AB here. So we call that Z in this case. Z is your hypotenuse, so it's 5 squared plus 2.92 squared. That's 33.5264. And then take the square root of that fella, and that's 5.79 inches. No problem. So if you know your Pythagorean theorem, and if you know how to do it quickly, right, just plugging in and go, when do you add and when do you subtract? That's really the question. But it's always square rooting. Classify DAB. Where's DAB? DAB. So I'm going to kind of DAB here. I know that across from D to B is 10 because it's 5 and 5. I know that this is 5.79, and this is also 5.79 because a kite, right? We know that these two are the same. Oh, sorry, folks. There it is again. DAB, I just draw the top of the kite. I know that this is 10 because it's 5 and 5. The 579 that I found for this side is the same here. So we're gonna, this is definitely isosceles, but now we need to check, is this an obtuse? Because it's the longest side across from it, there's a chance that is obtuse. So we go cosine of A. Remember, if I want that angle, I got to start off with subtracting that side across that angle at the end. And then it's 5.79 squared plus 5.79 squared. 2 times, and I'll tell you where you can stop. You can stop, just figure out what the top is. If the top is negative, is that? Oh. 1 second, I'll finish this. If this top is negative, then this is what? Obtuse, right? You remember that? You know, like a couple weeks ago we did that, right? So I'm going to go 5.79 squared plus 5.79 squared minus 10 squared, which is 100, right? It is negative. And I'm just going to go 9 dot dot dot. So because of that, it's obtuse. You don't even have to figure out the angle. You just stop there. You stop there. So this is an obtuse isosceles. I can just say stop here. Stop there. Don't proceed to figure out the whole angle. We don't necessarily need that. And almost done. Last one. We did this at the end of yesterday. Consider the following regular. It's a regular polygon, means all sides, all angles are the same. So AB is 12. This is 12. And this is 12 as well. So because these sides are the same. Calculate the central angle. This is my central angle here. Central angle is simply 360 divided by the number of sides. So we're going to go 1, 2, 3, 4, 5. N is equal to 5, right? So we go 360 divided by 5. That's 72 degrees. That's all you needed to do there. Calculate the perimeter of the polygon. I'm going to find x first. X squared, I should say, is 12 squared plus 12 squared minus 2 times 12 times 12 times cosine of 72 degrees. That's 199.003, and that keeps going. Take the square root of that guy. That's 14.1068. Perimeter is 5, because there's 5 sides. Perimeter is 5 times 14.1068. So the perimeter is 70.53. We are in centimeters, and it's just centimeters, not centimeters squared. And the bonus. You basically need to take one triangle. This one here. We know this is 12. This is 12. And the bottom here we just figured out is 14.11 basically. Right? Because this is the x we found. We're going to have to cut this to find the height. So this is 12. This is 7.055. So the height is 12 squared minus 7.055 squared. Square root of that. Square root of 94.226 keeps going. That's 9.7071 centimeters. Therefore, the area is base. So I'm going to go back to the original base times the height I just found divided by 2. And all of this, folks, watch this, square brackets. How many of those triangles do I have in the pentagon? 5, right? Yeah, times 5. So I will find the area of just one triangle. Which is 68.48 times 5. And that's 342.42 squared centimeters. This is bonus material only. I will not put this on a test, but if you want to score bonus marks, this may or may not show up, something like this. So now you know at least how to do that one. What I will do is this. Test review number 2. Where do you want to write this down? I will do this here at the bottom. Test review 2 is page 2 to 5. Page 2 to 5 in the booklet. And the key will follow. I will also add this maybe on page 204. Page 204 in your actual note booklet. I will add that as well in there again, just so you have it and you don't forget. Okay? Test review number 2, page 2 to 5 in the booklet. I will post the key to that as well. And Brad, I will answer some of those questions tomorrow, okay? I will go over those 2 reviews. Tomorrow's Wednesday. So